Wow, hi fourth graders. In this lesson we're going to really focus on how to interpret remainders when we're doing division. But before we do that, I thought it would be a good idea if we actually review how to divide with and manage remainders. So I have a problem, 29 divided by 7. I can write it both ways. Here's another way to write it, 29 divided by 7. We know in both cases that the 29 is the dividend and the 7 is the divisor. And we're trying to solve for the quotient, but since we see that 29 is not a multiple of 7, we know we're going to have a remainder. Then we have to decide in our lesson today what we do with the remainder, how we look at it. So the first thing we want to do is we want to see what multiple of 7 is closest to 29 but does not go over or cannot be greater than 29. And if you look at your 7's multiples, you can see that 28, and I can write it here this way or I can write it over this one, 28 is the multiple of 7 closest to 29 without going over. And then we have to think, well, 7 times what is going to get us to the 28? And we should know that 4 is the answer to that, so that 4 times 7 is 28. But we had 29 objects, so that means we have something that's left over or remaining. And when we see the difference between 28, which is 4 times 7, and the total number of objects we had, which was 29, we realize that our remainder is going to be 1. And the answer would be the same here. It's just written over here. And remember that our answer to a division problem is called the quotient. So what do we have? We have 29, the dividend, divided by 7, which is the divisor, equals 4, which is the quotient, with a remainder of 1. Alright, so hopefully that brought back some understanding from our lessons that we've had prior to this lesson. And now what we're going to do is we're going to look at what we do with remainders. If you remember, there were 4 things that we can do with a remainder. How we handle the remainder all depends on what is the problem, what is the word problem, and what is the question that's being asked. So let's review the 4 ways to interpret a remainder that we briefly discussed today. Number 1, we can use the quotient, which is the whole number portion of our division answer, and write the remainder as a fraction. So we could have an answer like 3 1/2 cookies. So an example for an answer that might be where we write the quotient and then use the remainder written as a fraction would be if you had anything. It's used when items can be cut or divided, like cookies, lumber, ribbon, material, paper, anything that you can actually physically make smaller and it's still usable as a fractional part. So, like today, an example might be 3 1/2 cookies, because you can certainly cut a cookie in half and eat it. Another way is to actually just ignore the remainder and just use the quotient or the whole number part of our answer to our division problem. And this is used when the question asks for whole objects, like today, how many whole cookies could you eat if you were sharing 3 cookies with your friend? Sometimes questions would say, how many full containers would you be able to get when you're filling containers with whatever the dividend number is, or filled boxes, etc. Example, answer might look like 4 boxes of cards. You really would have leftover cards that couldn't fill boxes. So you would just ignore your remainder in that case. Now number 3, you could sometimes use the remainder as the answer. Remember today we asked if you each could have whole cookies when you had 3 cookies shared between 2 people, and I asked how many cookies would be left over. The answer would be 1, because now we're asking how many aren't going to be used. So it's used when the question asks how many were, here's a keyword, left over, or could ask, or couldn't fit in the container. Some sort of wording like that in your question for your word problem. Now we haven't done anything with this yet, and this one is really the 4th way to interpret a remainder. you don't use the remainder, but you actually round up the quotient or the whole number portion of your division answer to the next whole number. This is used when all of the objects in the dividend must be included in your answer. For an example, if you went on a field trip and you ended up that you needed four buses to take all the kids, and you had a remainder of 3 children left over that couldn't fit on 4 buses, you don't want to leave the 3 children behind at school. They need to go on the field trip also. So in something like this, the number of buses needed, they have to round up to 5 buses. And the reason why we need 5 buses is that is so all students can go on the field trip. You have to be patient with interpreting remainders, guys. It takes lots of practice, discussion, and time to fully apply this skill. So we're going to be working with it over time. We're going to be focusing today on it, but basically it's going to take us a while. Now, I want to take a look at a couple problems that we have on one of the pages we're working on today. And one of the problems is this really adorable sock puppet, and Cho is making sock puppets just like the one in the picture. Now the question is, if she has 53 buttons, how many puppets can she make? Well, the first thing is I have to realize how many buttons do I need to make the sock puppet. And if we count all the buttons, we realize that we're going to need 5 buttons per sock puppet. We also know how many buttons we have in total. We have 53 buttons in total, and I'm going to write my division problem like this. All right? Just because this is another way we can write it. So we have 53 buttons in all, and because we need 5 buttons per puppet, we're going to make sets of 5 to find out how many puppets we can make. Now if we think about multiples of 5, we realize that the closest multiple of 5 to 53 without going over 53 is 50. Remember, we cannot go above our total number, our dividend number. So 50 was the closest we could get. Now, how many 5s or sets of 5s are in 50? Or another way to ask that is 5 times what, which is going to become our quotient. 5 times what equals 50. And I think all of us would easily agree that 5 times 10 is 50. Now, that means we can make 10 puppets because each puppet needs the 5 buttons. But that only uses 50 of our buttons because 10 times 5 is 50. And we had 53 buttons, which means we're going to have some left over. And in order to find our leftover buttons or our remaining buttons, we're going to subtract how many we'll be using from the total number we had. And that's going to be 3. And so we're going to have a remainder of 3 buttons. Now in this case, those 3 buttons don't do us any good because that won't make a complete puppet that needs 5, 2 for the eyes and 3 for its buttons. So our answer to this, how many puppets can she make? She can make 10 puppets. Now what did we do with our remainder there? Do we write the 3 anywhere? No, because the 3 is not important to the problem. So in this case, this would be how we interpret this remainder of 3 is that we basically ignore the remainder and just use the quotient as our answer. Now, here's a hot problem. Pose a problem. Write a question about Cho and the sock puppets for which the answer is 3. So I'm thinking that maybe I could say that Cho has 18 buttons. So I could write that Cho has 18 buttons. Cho has 18 buttons. How many puppets can she make? And I changed the number of buttons. Sorry for my bad handwriting. How many puppets can she make? All right, and that answer is going to be, I'm thinking backwards, that answer is going to be 3. And I knew that, and I chose 18 on purpose because I knew 18 divided by 5 would give me a whole number of 3. It gives me a remainder of 3. But you see, again, I have to ignore that remainder because I can only make 3 complete puppets with only 18 buttons. Alright, so that's just the one I did. I want you to try to make up your own question about these puppets that would have an answer of 3 with your partner. Now down here it says, how many more buttons will Cho need if she wants to make 12 puppets? Question number 1 is that we know she has 53 buttons. Alright, she has 53. She'll need more buttons to make 12 puppets, but we just right now don't know how many. Now, first of all, we have to figure out, well, how many buttons would she need for 12 puppets? So to make 12 complete puppets, we're going to ask the question, 5 times 12. If you know your 5's times table, you don't have to do it as double-digit multiplication. You know 5 times 12 is 60. Now she would need a total of 60 buttons to make 12 puppets. So the first thing we'd have to do then, step 1, if we're going to explain, we can do this in steps like this. We do 5 times 12 equals 60 buttons. And then our second step, since they already told us how many she has, is that in order to find out how many more buttons she needs, we're comparing 53 to 60, and whenever we compare two numbers, that's a subtraction problem. So I can put 60 up here, and I can subtract 53 from 60, and I hope you know that that's 7. So our second step, remember when we explain we can show our work, we can say 60 minus 53 equals 7 buttons. And then you can just write it out if you wish and say, Cho needs 7 buttons. Okay, Cho needs 7 more buttons. Alright, now I do want to come over and I want to try one last problem down here. And it's a hot skill also. Now Jonah cuts a board that is 33 inches long into 4 pieces of equal length. He uses the pieces for the size of a picture frame. He puts an extra 2-inch wide trim on each side of the frame. How wide is the final frame? Wow, this is a hot skill. Well, first of all, we know that if he's cutting a board, we're going to use our remainder as a fraction, because you can cut things into 1/4 inches and 1/2 inches, so we're going to use our remainder here and report it as a fraction. So the first part of our problem is 33. The whole board is 33 inches long, and we have to divide that by 4. So let's take a look. What is the multiple of 4 that is closest to 33 without going over 33? And that is 32, because we know 4 times 8 is 32. Now that leaves us 1 inch, as 33 minus 32 is 1 inch. We have a remainder of 1, but we can report that as a fraction. Now if you recall today, if we're going to take our remainder and report it as a fraction, the remainder becomes the numerator in the fraction, and our divisor over here becomes the denominator of the fraction. That's how we use both the remainder as the numerator and the divisor as the denominator. So each of the 4 pieces is 8 1/4 inches. Alright, so we've divided 33 inches into 4 lengths, which is 8 1/4 inches each length. Now it says here that he puts an extra 2-inch wide trim on each side of the frame. If we were to picture our frame, and I'm going to draw a picture, so that's 8 1/4 inches, and that's 8 1/4 inches, which means that, because we cut them in equal lengths, and this would be 8 1/4 inches, and this is 8 1/4 inches. What he's done is on each side, he's added a 2-inch wide, this is going to be a 2-inch wide trim on each side of the frame. So he's added another bit of frame to the side, 2 inches to either side. Now it's asking how wide is the final frame. So if you look at this frame that I've drawn, because I couldn't picture it till I drew it, I have my 8 1/4 inches here, and then I have the 2-inch wide trim on this side and the 2-inch wide trim on this side. When I add all of it together, which is 8 1/4 plus 2 inches plus 2 inches, what I'm going to do is add my whole inches together first. So that's 8 plus 2 plus 2, which is 12 full inches. And then we have the 1/4 inch, that is when we divided the 33 inches into 4 equal pieces. And we were able to report the fraction, the remainder as a fraction. So our final answer is 12 1/4 inches. That's the final width of the frame. Well, I hope this helped. Please don't be discouraged. As I said, it's going to take time to fully apply this skill with lots and lots of practice. So we're going to tackle it today, and stay patient with yourself and each other, and we'll be successful as long as we stay in the struggle. Thanks, guys.